In this video, I'm going to explain the cartoon for the molarity of the molecules. And also, I will show you how to do the back of the question and answers, the table here. And then the rest of the questions here, you should be able to get that. So first of all, in this cartoon, we mentioned again before that when we have yes polar, yes winner, yes dipole, yes the symbol, how do I know that I need to draw the dipole is when the delta En is between 0.5 to 1.7 or greater than 1.7 no matter. So then we draw dipole. And when we have no polar, no winner, no dipole, no symbol, is when you have the delta En between 0.049. Now, when we have dipole, we have winner. We have winner meaning we will share the electrons unequally. And when we have no winner, then we share the electrons equally. Okay? So if you look up this picture, if you look closely, okay, this N, the polar, the bond, is N, the bond, only the bond, okay? And you can tell that because the delta En between the N and N, if you take the En of N nitrogen minus En of the nitrogen is 0. So they have the 0 number, the delta En. Now, because delta En is 0, meaning that there's no winner. Okay, that means they share electrons equally, so no winner, we're not going to draw a dipole. That's why you see that on the top of the N, I don't draw a dipole. And then if you're talking about the overall molecule, then we will start to talk about the triple bond. Now here, please take away the electrons because this is supposed to be molecular shape. I should not have electrons on it. Now the whole molecule, because I don't have any polar bond, okay, I have only non-polar bond, okay, non-polar bond. And because I have non-polar bond, meaning over all the molecule, my molecule is also have no winner. So the whole molecule is called non-polar because there's only like non-polar bond. And so we saw the molecule is non-polar, so then overall I will not draw the dipole on the top of the N, triple N. So you can see that the polar pairs actually they share electrons equally. And then the next thing is CO2. Now, CO2 molecules are nonpolar. Why? Because, again, you have to look at bond separately. If you look at this bond only, if you read it, CO2 has 2 dipoles, 2 polar bonds, but the CO2 molecule itself is not a dipole because the dipole cancel. So the overall molecule is nonpolar. So why do I say that? If you just look up this, okay, penguin and the polar bear. The penguin is carbon, the polar bear is oxygen. If you just look up this, there is a winner. The winner is the polar bear. You see this polar bear pull the ice cream to himself. So you see that I do have dipole on the CNO. You see that I draw the dipole on CNO. Okay, it took this ice cream from the penguin to the polar bear. If you look at this side, also same thing. The right side polar bear also pull the ice cream away from the penguin. So you can see that I also draw the dipole from C to O. So in this case, I do have 2 polar bonds. One polar bond go to from this C to this O. The other polar bond go from this C to this O. I do have 2 polar bonds. I draw the dipole because if you look up the delta En between O and C, if you find out the En of the C from the En of O and you subtract and you take absolute value, you get 1.0. Then 1.0 is in between this category, so we have to draw dipole. And the dipole, the winner is the oxygen. That's why we draw the dipole from C to O. For the bond only, So if you just look up the bond only, just one bond, also one bond, okay, I will have 2 polar bonds. But if you look it up, this is a linear shape, okay, this is a linear shape. So let me just put this down. This is a linear shape. This is a linear shape, okay, it's a linear 2 shape. It's a linear shape. So the linear shape, meaning that the 2 dipole, they are cancel each other because these 2 dipole are the same. Like C to O, the delta En is 1.0. C to L, the delta En is also 1.0. So they have the same dipole, but they're in opposite direction. The linear shape, they are symmetrical, so-called. So linear shape is symmetrical. Linear shape symmetrical, that means they are opposite but the same. So they go to the right, one go to the left. So that as a result, this dipole cancel. That means if you look up overall molecule, no winner. No winner. The overall molecule is no winner, nonpolar. Okay, so overall, the molecule is nonpolar, so we don't draw the dipole on the CO2 at all. We draw the dipole on CO. We draw the dipole on CO, but overall they cancel because the linear shape is symmetrical. Now, if you look up the H2O, now H2O, first of all, you should change your symbol to be like this. I don't know if I tell you in class, because bond only, so we should draw only H and O, okay? Please erase it, the previous picture that I've shown you. Now, the H and O, the delta En between H and O, right? We find the H, find the O, En, we subtract and take absolute value, we found it's 1.4. 1.4, it is in between these categories, so we have to draw a dipole. Now the dipole is from H2O because O is bigger number. So we do have two polar bond, okay? There's a one polar bond from H2O, there's one polar bond from H2O. You see that this polar bear, right? For this bond, the polar bear win over the penguin. There's also polar bear win over the penguin. So we do have two polar bond. But if you look up this shape, do you notice that this shape is actually band shape? Okay, this band shape is non-symmetrical. Okay, non-symmetrical. This is a V shape, kind of like a V shape, a band shape. So it's not symmetrical. So you can tell that, see the band shape. Okay, so you can tell one dipole goes this direction, one dipole goes this direction. They did not cancel, but they are added or they so-called combine. Okay, so this dipole, what is the result of this dipole? It's kind of like a combined dipole. Okay, so like a vector. Okay, these two go all to the top, and this is the final dipole. This is the final dipole, and then there's nothing on the bottom. Right? These dipoles go to the top, but there's no dipole on the bottom to cancel. These two small dipole combined as the top one, and nothing on the bottom to cancel. Okay, so as a result, all the polarity go to the top. So the molecule is polar, and so then as a result, we draw the dipole on here. Okay, so the water is polar because eventually you have a winner. The winner is the polar bear. Okay, and HCl is polar molecule, right? Because if you look at the bond only, the delta En is 0.9, so we do have to draw the dipole for the bond HCl. All right, so we have a one polar bond, and Cl is the winner. And if you look at the whole molecule is only like just HCl, nothing else. So if you look at the whole molecule, because I have a polar bond, so that's why, and nothing cancel. So everything goes to one direction, goes to Cl. So the molecule is also polar, and that's why I draw the molecule with a dipole. Okay, so this is the cartoon. Now let me talk the back. Okay, let me talk the back. All right. Now HF molecule is what? Polar, non-polar. So let's look up the bond first. So HF, no other molecule, just H and F, right? Just one bond, H and F. Okay, if you look up the electronegativity, hydrogen is 2.1 and F is 4.0. So if you find the delta En between hydrogen and fluorine, you take 2.1 minus 4.0 and you take absolute value, my delta En will be 2.9. My delta N will be 2.9. So my delta N is 2.9. That means I'm falling with this category is greater than 1.7, no metal. So that means I do have to draw the dipole. Now, where the dipole goes is from small to big. Because hydrogen is 2.1, fluorine is 4.0. So that means I have to draw from hydrogen to fluorine. Okay, so that means I have one polar. Okay, I have one polar bond. One polar bond. Okay, now what does that mean? Okay, my F is the winner. Right, my F is the winner. Oh, yes, I do have to draw the dipole. That's why I draw the dipole here, because F is the winner. Now, if you look at the overall molecule, well, HF is only one bond, which is like just HF, nothing else. Okay, so then the molecule is also polar. Okay, this is called one polar bond. This is called polar molecule. Now, because it's also go to one direction from the H to F, no other bond. So the molecule is polar. The molecule is polar. That's why we gotta draw the symbol. We gotta draw the symbol from H to F for the whole molecule. And so as a result, HF is polar molecule. All right. Now number 2, H2S molecule. Okay, so we first draw the bond first. So the bond is, I have 2 bonds, H2S. So I'm gonna draw H and S. Okay, because I can show you that if you draw the Lewis structure, your bond Lewis structure actually looks like that, HS, HS. So I'm going to talk about just HS. Don't draw HH because there's no bond between X and H. I only have bond H to S. So for this kind of question, you have to draw the Lewis structure first. Okay, so I draw the Lewis structure HS. There's no bond between H and H, just HS. Okay, so I'm going to draw H. S, that's the bond, and I have 2 of them. Now, if you look up the electronegativity, hydrogen is 2.1, and then sulfur is 2.5. If you do subtraction 2.1 minus 2.5 and take absolute value, your En is 0.4. Now, the En 0.4, if you look up back here, En is 0.4. Is in this category. So we don't draw dipole. We don't draw dipole. No polar, no winner. We don't draw the dipole. So that means I should not draw anything on here. Okay? Just go back to circle this distant molecule. Just go back to draw this. Okay? So we don't draw any bond because the bipole, because delta En is 0.4. So in this case, no winner because 0.4 meaning no winner, so no polar. So that means I have non-polar bond. I have non-polar bond. Now, how many non-polar bond? If you look up the Lewis structure right here, this is 1 non-polar bond. This is 2 non-polar bond. So I do have 2 non-polar bond. So let me just go back. 1 polar bond, polar molecule. I'm afraid that you guys will not understand that. Okay? So 1 polar bond and 1 polar molecule. And here I have 2 polar bonds. Okay? So then I can write the sentence is no winner. Got no winner because the delta En is between 0.0 to 0.49. No winner. So as a result, we don't draw the dipole. So we just leave it like that. And then when we start to draw the molecule, you do the Lewis structure, and you find out it's a band structure. Okay, it was a band structure like this. Something like that. Okay, so you can tell, because I don't draw any dipole, So this will be a polar molecule, actually will be a non-polar molecule. Non-polar molecule. Okay, because I don't have any dipole, so no winner. Okay, so then the molecule is non-polar. So that I also draw no dipole on the whole molecule. You see that the whole thing, I draw nothing. If you look up here, if you compare, the water is different because they look like the same, they're band shape. But if you compare, why do I need to draw dipole? It's because the H and O, the delta En is 1.4. That's why I draw the dipole here. But HS, the delta En is 0.4, so I don't need to draw dipole. So as a result, H2S is non-polar molecule, but the water is a polar molecule. Okay, so which is different. So the H2S should be nonpolar. Right? Now, next one is O2. So O2, the only bond you can have is just the oxygen. Just the oxygen. I forgot to draw the circle here. So this is my non-polar molecule. Now O2. So then, if you find out the delta En, obviously, delta En is 0. Delta En 0. So that means I don't need to draw dipoles. So then, how many bond here? If you look it up, I only have one bond. If you draw the Lewis structure, I only have one bond. So I would write one non-polar bond. One non-polar bond. Okay, so then I would say no winner. So then I don't draw any symbol. So I don't draw any symbol. I leave it like that. And then for the whole molecule is actually double bond. Okay, now because I don't draw any dipole, so then my molecule is also non-polar molecule because I don't have any winner, because I don't have any dipole on the picture. So non-polar molecule. So that means is the molecule is nonpolar. So that's why we don't draw any symbol at all, because I don't have any arrow. So oxygen molecule is nonpolar. And this is the answer. And finally, SiO2. If you draw the SiO2 Lewis structure, you'll find out the molecules looks like that. I have two bonds, O and Si, and then the other one also O and Si. I don't draw any bond between O and O. There's no bond between O and O. So I would draw, I have Si. I'm sorry, this should be just single line, okay? It's a single line, okay? It's a single bond here. Si and O. And then if you check the delta En, the delta En is 1.7. If you check the delta En between Si and O, is 1.7. The 1.7, I don't have any metal. So that means I do have to draw dipole. So the dipole will go from the Si to O because O has a bigger number. Okay, then how many polar bond I have? Like this is when I draw the dipole means I have polar bond. So how many polar bond I have? If you draw the picture, I have two of them. I have one here, one here. So I will write I have two polar bond. I have two polar bonds. Okay, so why was that? It's just like who's the winner? The O is the winner. O is the winner. So I do draw the dipole. Okay, I drew the dipole from Si to O. Now, when you talk about the whole molecule, after we do NaSl, we find out the molecule looks like that. Looks like this. Okay, so we go ahead to copy this symbol. We go from Si to O this way. We also go from Si to go this way. Now you can see that there's a linear structure. So then the dipole are the same. Si to O, delta En is the same thing as dipole Si delta En. They have the same delta En 1.7, 1.7, and they're linear shape. So eventually, my dipole is cancelled. That's the answer, like right here. Okay, you see that my dipole is gone, no more. This is my final thing because they are the same dipole, but they're opposite direction. They're linear, they're symmetrical. So my overall is non-polar molecule. Non-polar molecule. Okay, so I would say the molecule is non-polar. So then I don't write any symbol. Now again, why this is cancelled is because they have the same dipole. Okay, so I can write on here if you don't understand the notes. The notes is same dipoles, two same dipoles, but they symmetrical Okay, they're symmetrical, so they cancel. So they at the end of the cancel, then no winner. So then that's why we write non-polar molecule. So this is the result will be non-polar molecule for Si2.